All right, hi friends. Today we're going to be working on 5.4. This is the notes packet. This is the ones that you've not seen before from Algebra 1 land. Right now I am recording live from 7th hour, so you will hear my 7th hour students. I'm sure some of them can never keep quiet. All right, so number 1 talks about a painter. They have exactly 32 units of yellow dye, 54 units of green dye. This painter plans to mix as many gallons as possible of lime paint and gecko paint. Each gallon of lime requires 4 units of yellow, 1 unit of green. Each gallon of gecko requires 1 unit of yellow and 6 units of green. Find the maximum number of gallons of color he can mix. First thing we do is figure out, in these types of inequality problems that have restrictions, that's what these problems are. They're inequality problems with restrictions. You want to find out, is this going to be a minimizing problem or a maximizing problem? So, those of you in here that want to be on YouTube, tell me, is it minimum or maximum? Maximum, all right. And it's even in there, in the problem, that's really cool. So it's a maximum. All right, so this is, this is where you need highlighters. Yep, this is that section. So first we need to figure out, what are we trying to maximize? So what is the noun that we're trying to maximize?
Gallons.
Okay, so now we need to take it a step back. So not just gallons, but
Number of gallons.
okay. So yeah, so we're going to try to maximize the number of gallons. This is also where students get confused because of the wording in this problem. So I'm going to say my variable x is the number of gallons of what?
Paint.
Which paint?
Each color he can mix.
Yeah, but which color?
All of the colors.
No, because we need to actually define them separately.
Oh, yellow.
No.
Okay.
Yeah, and that's where that's where students make mistakes, because when you see color, don't you immediately go to what the two colors are there? Yeah, but that's not the actual name of the paint.
Lime.
Yeah, so lime, yes.
Gecko.
So X is the number of gallons of lime paint, and Y is the number of
Gecko.
gallons of gecko paint. Good so far?
Awesome.
Like, you don't have to put X with lime, right? Like, you could do X and gecko paint.
Oh, like swap them? Yeah, it'll just look different than mine.
Okay.
Good so far? All right. Next thing that I want to do is I want to highlight all of the things that are similar in the problem, and I'm going to put an asterisk next to similar. Actually, I want to highlight all the things that are the same. So if it talks about something multiple times, it's generally what we call a restriction. So I'm going to grab my yellow highlighter. Do you see any words that appear multiple times? Yellow, yeah. In fact, we only have 32 units of this yellow dye. I'm going to tell you, if you're a heavy highlighter like me, you want to be careful because you want to be able to use the back of this page. And then I then have 4 units of yellow dye, so that's another one that uses yellow. And then it looks like there's 1 unit of yellow dye. Then I'm going to grab my green highlighter and highlight the other thing.
The green dye.
So 54 units of green dye. And then each gallon of lime uses 1 unit of green dye and 6 units of green dye. So in this problem, I'm restricted. I can't just use as many units of dye as I want. I kind of have like a bound, an upper bound, a maximum number that I can use. So the way that I set this up is actually a little bit different than you would see even online. Other teachers that I've seen this, they set it up differently. I like this method because it works better for the way that my brain works. If at this point you're like, what, Mr. Brumman? I need a different way. If you go online, many problems They show it in a different way. I like to set it up so it looks kind of like a table. I like to put my X column, so I have an X column. What did we say X was again?
Lime.
Number of gallons of lime paint.
Yeah. Here I'm just going to abbreviate with just lime. But you're totally right. And then Y was what?
Gecko paint. Sorry, number of gallons of gecko paint.
Yeah, and I'm just going to put, and again, for my column abbreviations, I'm just going to put gecko. And then now for my rows, I put anything that creates a restriction. So what is one of my restrictions? What am I limited on? The amount of yellow dye that I have, so that's one of them. So over here off the side, I'm going to put the word yellow. So the yellow dye is one restriction. What's another restriction?
Green dye.
The green dye. All right, so now what I do is I kind of set up, so in this table, if I find where these intersections occur, then I can pull the number from the problem. So what I'm looking for is how many units of yellow dye do I need for lime, knowing that lime is X. 4 units of yellow dye, so that's going to be 4X. How many units of yellow dye are used in the gecko?
One.
So 1Y. And then we said we had kind of an upper limit or a maximum. What was that?
For each one, oh.
32.
32, because we only had 32 units of yellow, right?
Right.
Okay. So now let's think about the relationship with these. What am I doing with these? Adding,
Adding.
combining, and then I need an inequality symbol.
Well, it can be less than or equal to 32.
That is correct. It can be less than or equal to 32. Because I can't use more than the number of units of dye that I have. Does that make sense?
Yes.
General nods from students in the classroom. So, green. How many units of green do I use with lime?
1.
Plus,
6.
and then I have 54 units here. Do I have any other restrictions? No. So on all of these problems that you have in your packet, you will have 2 variables. You might have more restrictions. This is also where students get messed up because they'll get to this point and they'll try and make 3 variables because we've done 3 variables recently. If you're getting to the point where you think you have 3 variables, you've flipped them. What you actually are trying to do is change the restrictions. This will make more sense in the next problem when I show you like what students do and you'll be like, oh, okay, I see that. So just bear with me on that part. Okay. What I want to do now is graph these. I'm going to put these in slope-intercept form. So I'm just going to do the work for that here off to the side. So I've got 4x plus y is less than or equal to 32. So I'm going to subtract 4x on both sides. I get y is less than or equal to negative 4x plus 32. We okay with that?
Yes.
Okay. And then I have x plus, ooh, don't die on me, green pen. X plus 6y is less than or equal to 54. Subtract x on both sides. 6y is less than or equal to negative x plus 54. Then what do I do? By, on, fantastic. Divide by 6 on both sides, and we get y is less than or equal to negative 1/6 x plus 9. All right, I tell students to make a graph, make a coordinate plane, and what they do is they want to put the coordinate plane in the middle, like that. That doesn't make sense. Can you have negative gallons of paint? So in any real world problem that you have, in fact, all of the real world problems in this packet, it's always assumed that x has to be greater than or equal to 0, because you can only have 0 gallons of paint or more. Same with y. But I'm not going to graph those. Instead, I'm just going to set up so that we're only graphing in the first quadrant. Does that make sense?
Yeah.
Again, general nods from students. And yes. All right. All right. Now, I'm going to give you a wonderful piece of information. The number of squares going up and down is 22. And the number of squares going left and right is 30. You probably want to write that somewhere. You'll want it later. 22 up and down, 30 left and right. Which means I can't go up by ones, because the graph won't fit. So instead I'm going to go by twos. So I'm going to put the origin down here. Then I'm going to go up by twos. And I'm going to go to the right by twos. 2, 4, 6, 8, 10. And the way I'm marking it, I'm just marking every multiple of 10. 12. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 30, 32, 34, 36, 40, 42, 44, 46, 48. If I did it right, I should end up at 60. Yep, sweet. You may have noticed I switched colors when I was doing each of these inequalities over there. That's so that I can graph them using a different color. It's just easier. So I'm going to graph this one first. The y is less than or equal to negative 4x plus 32. So I'm going to make my y-intercept at 0, 32. Now, when I go and do my slope for this, how do I account for the going by twos? Like, can I go down 4 squares into the right 1 square? Does that work?
No. Two squares and then halfway.
You got it.
So if I do that, then that does that. So if I go down 2 and then, so what I'm doing is I'm going down 1, 2, 3, 4, and then over to the right 1. But if I do that again, I end up here. Wait, isn't that the same as going down 4 into the right 1? How come it worked? Well, it works because what you've preserved is what's called a 1-to-1 correspondence on your scale. This is super important. This is one of those things that graphs can do to mislead you, is they can change the scale. Like the x-axis and the y-axis go by different amounts. They don't here. We're going by 2, but we're going by 2 in both directions. So it still holds. Like you can still go down 4 to the right 1. It still works just fine.
Stellar.
Now, I'm still filling in that spot between them. Because that spot or that point may be what we call a critical point. We'll get to what a critical point is here in a bit. The next thing I'm going to do is I'm using a straight edge. You want to make sure that you're using a straight edge on these. On your homework, if you don't use a straight edge on one of the problems, you may get the wrong answer. Your homework for this section is going to be the other packet of 1, 2, 3, and 4 that follows this.
Wait, do we get another packet or is it?
It's in the one that you have. I'm sorry. I said other packet. I should have said that the papers that follow this one.
Which one?
1, 2, 3, and 4.
This is not one.
This is 1. And then you should have a 2,
Yeah.
and then a 3 and a 4, and then you have another 1.
Oh, so now these are the homework.
Mm-hmm.
The second set.
Yep.
Okay.
I need to shade this. Which way do I shade?
Great.
Yeah, below, because it's going to be less than. If I use a test point of 0, 0, it's going to be true. And that's just me doing it quickly and just knowing, okay, if I put in 0, I know that 0 is less than or equal to 32. So I'm very lightly doing that because it'll bleed through if I go heavy with this. In fact, it probably did bleed through anyway. There's that one. Good so far? Now the next one, my y-intercept is 9. Now, be careful because 9 is halfway between 8 and 10. Remember, we went up by 2s. So you got to be careful with this so that you get in the right spot. Now my slope is negative 1/6. So I'm going to go down 1 and then to the right 6 on my graph. That goes through this point here that's already there. Generally, you will see on these problems that you end up going through the same point. That's a good sign. That usually means that's the solution. Go down 1 into the right 6. Go down 1 into the right 6.
When you say go down one, is that starting from the 9? So you're just going halfway?
So I'm just going down a half of a square, which is 1 unit. Yeah, I'm going down 1 unit on the graph, and then I'm going to the right 6 1 units on the graph,
Okay.
which is really 3 spaces. Yep,
Yeah.
that's why you're seeing a discrepancy. And we end up there. Notice I'm not making these lines. I'm making these line segments. They can't go into the negatives. We can't have negative gallons of paint, so it has to stop there. Again, connecting it. Then shading. Where am I shading on this one? Below, because if I put in 0, 0 as a test point, it's still true. And this is where if you use 2 primary colors, it makes a secondary color.
No. Green. Brown.
Good so far? All right. Now we need to note the critical points. The critical points are the points along where we have the intersection of both, in this case, both restrictions. Sometimes it's all restrictions. You might have more than 2 restrictions. So there's a critical point, there's a critical point, there's a critical point, and there is a critical point at the origin. Mr. Drummond, if we're trying to maximize something, are we really going to use nothing of it? You're exactly right. That's not going to be the answer. So I know that one's not going to work. The other ones might. Before we get in any farther, I do need to label my axes to make this make sense. So, what's my x-axis label? Don't think too hard about it. You already have it written down.
Green.
Close.
The gallons of water.
The number of gallons of lime.
Yeah.
Oh my god. What's your IQ?
I know. I can't with those.
And then, what about y?
Gecko tank gallons. The number of gecko.
I think you have to say it word for one.
The number of gallons of gecko paint.
There we go.
Oh, you just added an accent.
So why am I putting that whole part? Well, that actually helps me with what the end goal here is. What am I trying to maximize? Again, we said that earlier.
The number of gallons each color can make.
So the number of gallons of gecko and the number of gallons of lime. That's what I'm trying to maximize. Like, that's the goal. So what we need now is an equation for this maximization problem. So to do that, if I know that I'm trying to get the maximum number of gallons, how many gallons of lime paint are in a gallon of lime paint? 1. So that's 1x. Plus, how many gallons of gecko paint are in 1 gallon of gecko paint?
1.
1, also 1. So it's 1x plus 1y. That's my maximization function. Mr. Bromond, that seems really easy. It is for this particular problem. This problem is to showcase other parts that are tricky, not this part. We'll see a problem where it is not just simply x plus y here in a bit. Okay with this? Now I need to check all of my critical points to see which one is the best out of these scenarios. So 0, 0 is the origin. I know that one's probably not going to work. What are these other critical points? Be careful. 0, 9. 6, 8. Yep. And I did them in that order. Different than how we said it. If you need to, you can watch the video.
Yeah. I don't think it will help.
0 plus 0. So then I have another column for my max. What's 0 plus 0? 0. What's 0 plus 9?
9.
What's 8 plus 0?
8.
What's 6 plus 8?
14.
Okay, so which one gives us the maximum?
14. Nice.
So, to get a maximum of 14 gallons, of paint, we would need to make 6 gallons of lime and 8 gallons of gecko. Questions on this one? If you're on YouTube, email me them.